Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 8.3, Graphing Quadratic Functions. Unfortunately, the recording crashed as I was just finishing this lesson, so I'm just going to give you guys a quick recap. So if I was graphing a function like f of x equals x squared plus 2x minus 3 by factoring, the first thing I need to do is factor. So what multiplies to negative 3 and adds to your middle term adds to 2. So we were able to factor that to f of x equals x minus 1 times x plus 3. Then we apply the zero product property. The zero product property is when you take your factors, you set them equal to 0 and solve. So if I put x minus 1 equal to 0 and solve, I get x equals 1. If I did the same thing for x plus 3, I'd get x equals negative 3. So my solutions are 1 and negative 3. Your solutions are also called zeros, x-intercepts, and roots. Those are all synonyms for each other. Okay? So what's this going to look like? So we could either have no solution if our parabola is going upward with a vertex above the x-axis. If it's a vertex below the x-axis going downward, that would also be no solution. If your vertex is below the x-axis going upward, your parabola is going upward, you are going to intersect the x-axis in two places. That would be two solutions. The same thing for a vertex that is above the x-axis with a downward parabola. That would also intersect in two places, giving us two solutions. You can also have one solution if your vertex is on the x-axis, either on it going up or on it going down. You're going to have one solution. It's only going to intersect the x-axis in one place. All right, so then once you do that, once you find your points, so let's give you guys a problem to go over. So you're going to factor. You know that your x-intercepts are at negative 1 and negative 3, so you're going to plot a point at negative 1, a point at negative 3. Halfway between those 2 points is your axis of symmetry, so you draw that dotted line there. Then you know that your vertex is on your axis of symmetry. So if your axis of symmetry is negative 2, you plug in a negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So you know that your vertex is at negative 2, negative 1. The next thing that you do is you need to find another point. So you can go for the y-intercept because that's an easy point to find. The y-intercept is when the graph crosses the y-axis. So that's always going to be when x is 0. So plug in a 0 and you get 0 plus 0 plus 3 or 3. So 0 comma 3. Once you have that extra point, you can just reflect it over the axis of symmetry. Count 2 to the axis of symmetry, 2 away, and that's your last and final point. And then you just create your graph. If it's going upward, it has a minimum. So this minimum is at negative 1. So it has a minimum value of negative 1. Your domain for all of these parabolas is going to be all real numbers because it's going to end up opening up forever, including all possible x values. In terms of our y values, the lowest point is negative 1. So my range would be y is greater than or equal to negative 1. And that's pretty much everything that you need to know about parabolas. We're going to do one more example on here. Or actually, I guess we'll do two. And then that way you guys have a couple examples on this video. So the first thing we're going to do on this one is we are going to factor it. What multiplies to 8? Well, we have 1 and 8, 2 and 4. Okay? So 1 and 8, 2 and 4. What multiplies to negative 8 and adds to positive 2? Negative 4, positive 2. Good job. So f of x equals x plus 2 times x minus 4. So our solutions, if we set these factors equal to 0 and solve, we're going to get solutions of negative 2 and positive 4. So the first thing we're going to do is we're going to graph or plot those points. So we have a point of negative 2 and a point of 1, 2, 3, 4. All right, so far we have 2 points of our parabola. We now are going to find our axis of symmetry, which is smack dab in the middle. 1, 2, 3, 4, 5, 6. So halfway is 3. 1, 2, 3. So our axis of symmetry is at x equals 1. I'm going to plug a 1 in and see what I get. 1 plus 2 minus 8. 3 minus 8. 5. Negative 5. Negative 1, 2, 3, 4, 5. Okay, so there's our vertex. We're going to find another point. Let's go for our y-intercept. Our y-intercept is when x equals 0. 0 plus 0 minus 8 is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That makes no sense. I messed something up. Probably this point, because these points are already there, right? So let's look. If I plugged in a 1, I had 1 plus 2 minus 8. 3 minus 8 is negative 5. So what did I do wrong? I plugged in a 0. I got 0 plus 0 minus 8 is negative 8. What happens if I plug in a 2? That'd be 4 plus 4 minus 8. 4 plus 4 is 8. 8 minus 8 is 0. Did I factor wrong? At this point, this point, this point. This is making no sense. What did I do? X squared minus 4x plus 2x is negative 2x. I factored wrong. You guys see that? X squared minus 4x plus 2x is negative 2x. We need positive 2x. So we need positive 4, negative 2, which makes this positive 2, negative 4. Positive 2, negative 1, negative 1, 2, 3, 4. Which changes that axis of symmetry. You guys see how I was able to figure out that I totally messed up by plugging in other points? So positive 2, negative 4. So that's 1, 2, 3, 4, 5, 6. So 1, 2, 3. Here's our real axis of symmetry. Are you guys seeing how if you mess up, it's just not going to make sense, and then you can figure out where your mistake was. So it's good to make a mistake, right? So then you guys can learn, because most of the time when you guys make a mistake, you're like, well, what do I do? Well, go back, FOIL back out, see if you messed something up, because obviously something had to have been messed up, and it's just a matter of time to figure it out. All right, so if I plug in a negative 1, I'd have 1 minus 2 minus 8. So negative 10. 1 minus 10 is negative 9. So negative 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would be reflected. We would reflect this. 1, 2 to the line, 1, 2 away from the line. And we can double check that. So that was at negative 1, 2, 3. Let's double check that. Negative 3 would give us 9 minus 6 minus 8. 9 minus 6 is negative 3. Sorry, it's positive 3. Minus 8, negative 5. Let's see. Negative 1, 2, 3, 4, 5. Perfect. Now this is looking right. We have a minimum value at negative 9, right? So our range is y is greater than or equal to negative 9. Our domain is all real numbers. Our vertex is at negative 1, negative 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And our axis of symmetry is x equals negative 1. All right, let's try another one. Let's not mess this one up from the beginning. So 1 times 10, 2 times 5. What multiplies to 10 and adds to negative 7? Negative 5 and negative 2 multiply to positive 10 and add to negative 7. X minus 2 times x minus 5. Our solutions are 2 and 5. Let's double check. X squared minus 5x minus 2x is minus 7x plus 10. All right, good. This time we're looking better. We have 2 and 3, 4, 5. All right, so smack dab in the middle is going to be at 3.5. X equals 3.5. Our axis of symmetry is x equals 3.5. So if I plugged in a 3.5, 3.5 squared minus 7 times 3.5 plus 10. 3.5 squared minus parentheses 7 times 3.5 parentheses equals plus 10. I got negative 2.25. Is that what you guys got? And then I could do, say, 1, 2, 3. Let's plug in a 3. So 3 squared is 9. 9 minus 21 plus 10. 9 minus 21 plus 10. I got negative 2. We can reflect it, but I also want to double check. So I'm going to plug in a 4. 1, 2, 3, 4. So I plug in a 4, I get 16 minus 28 plus 10. I get negative 2. So that's perfect. If I wanted the y-axis, the y-intercept, then that would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not going to cross till way up here. Right? And you can reflect that. But that is how you graph parabolas. I hope you guys enjoyed this lesson on 8.3. Your homework is on page 429 and page 430. Please like and subscribe and have a fantastic day.